Okey, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Fitri Ashraf bin Syariman daripada kelas DM4A. Nombor kad matrik saya 09 DM20F1006. Okey, hari ini saya ingin menerangkan tentang subjek kontrol sistem untuk chapter 4 yang bertajuk stability. Okey. Introduction. We have already studied the control system and how the various units of the control system work together to provide a specific system output. The system various parameters must be controlled to produce the desired outputs. Along with this, the system must be stable enough so that the output is not influenced by external factors. The undesirable variation in the system parameter or disturbance as a result, we can say that a stable system is designed to produce the desired system response without any intolerable variation as the system parameter change. It should be noted that stability or instability is a characteristic property of the control system and thus depend on the system closed loop rules. As a result, we can say that stability is a system factor that is independent of the system input. The steady state output of the system, on the other hand, is determined by the pole of the applied input. The stability of a system is classified as stable, unstable, and marginally stable. Okay, for a stable, all the closed loop poles in a stable system are in the left half plane. If a system output is under control, it is said to be stable. Otherwise, it is considered unstable for a given bounded input as a stable system produces a bounded output. The graph below depicts the response of a stable system. Okay, for unstable, at least one pole in the right half plane and or repeated pole on the imaginary axis characterize an unstable system. A state variable in a system is said to be unstable in dynamical system theory if it evolves without bounds. If at least one of a system state variable is unstable, the system is said to be unstable. Okay, for the last marginally stable, a marginally stable system has poles that are not repeated on the imaginary axis and possible poles in the left half plane. A frictionless pendulum is another example. A system with a pole at the origin is also marginally stable, but the response will not oscillate because the imaginary part is also zero. Jw equals 0 means W equals 0 radian per second. A mesh on frictionless surface is an example of such as a system. A marginally stable system is one that produces an output signal with constant amplitude and constant frequency of oscillation for bounded input. If any two poles of the open loop transfer function are present on the imaginary axis, the open loop control system is marginally stable. Okay, system stability method has two, Routh-Hurwitz and Boole-Plot. Okay, for the Routh-Hurwitz method, I give for my friend Muhammad Faris Al-Aiman.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Faris Al-Aiman bin Muhammad Faizal daripada kelas DM4A. Nombor kad matrik saya ialah 09 DM20F1002. Saya akan membentangkan tentang Routh-Hurwitz method. According to the Routh-Hurwitz criterion, any system is stable if and only if all the roots of the first column have the same sign, and if they do not have the same sign or there is a sign change. The number of sign change in the first column is equal to the number of roots of the characteristic equation in the right half of the S-plan. The number of root with positive real parts. Okay. Ni contoh rumus. Okay. We have no guarantee that the system will be stable if all of the coefficients have the same sign and there are no missing terms. To check the system stability, we use the Routh-Hurwitz criterion. If the aforementioned conditions are not met, the system is said to be unstable. Routh-Hurwitz criteria state, to stable system, if all the element in the first column have the same sign. Then all the source locate on the left side of the plans. To unstable system, if there is a change of sign in the first column, the number of sign change indicate the source locate on the right side of the plans. To advantage, it determine the number of zero characteristic equation on the right side of the plans without resolving the characteristic equation, and can use in the multi-loop system. Disadvantage is only capable of showing the number of zero characteristic equation on the right side of the plans without giving information about its position, while the information needs to design a system. Jadi ini contoh rumus. When the coefficient is 0, A1 and are all of the same sign and none is 0. Arrange all the coefficients of the above equation in two rows. From this two row, we will form the third row. Jadi kat sini ada menggunakan pangkas silang. Okay, step 3. Now we shall form fourth row by using second and third row. Okay, jadi ini contoh. We shall continue this procedure of forming a new row. Okay. The example. Okay, ini rumus. And obtain the row of coefficient as follow. Okay. Jadi ini contoh cara penyelesaian untuk rumus yang ini. Okay. Sekian daripada saya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Arif Anwar. My matrix number is 09DEM20F1004. Okay, kali ini saya akan sambung pembentangan dari rakan saya. Saya akan mengambil part board plot method. Okay, so ini adalah untuk cari kestabilan. Okay, a board plot is a graph that is commonly used in control system engineering to determine a control system stability. A board plot depicts the frequency response of a system using to graph the board magnitude plot in decibel and the board phase plot to expressing the phase shift in degrees. Okay, ni contoh-contoh ni. Ni adalah magnitude dan ni adalah phase, board phase. Magnitude dia gunakan dB dan phase dia menggunakan degrees. Okay. The board plot or the board diagram consists of two plot. Okay, dan saya cakap tadi dia ada dua, dia cari magnitude dengan phase. Okay, seterusnya magnitude plot. Magnitude plot tu, a board plot is a graph that show the magnitude in dB or phase of the transfer function as a function of frequency. Of course, we can easily program the transfer function into a computer to generate such plot. And in the case of extremely complicated transfer function, this may be our only option. Okay, phase plot pula adalah the phase margin is usually read directly from the board plot, as shown in the diagram above, like this. Okay, phase figure in degree. Okay, the vertical distance between the phase curve on the board phase plot, the x-axis is calculated at the frequency where the board magnitude plot. So magnitude plot equal 0 dB. This is referred to as the gain crossover frequency. Okey, ni adalah contoh yang kita orang dah buat. Ni adalah jadual dia, dan ni graf yang kita orang dapat. Dan bila dapat graf ni, kita akan cari gain margin and phase margin, GM and PM. Okey, sikit contoh dia. Ni adalah dia punya graf. Atas ni kita akan cari ni mewakili dua graf. Okey, satu kertas mewakili dua graf. Atas ni adalah graf untuk magnitude board, iaitu G, dB. And ni adalah phase in degree. Okey, so ni adalah dia punya paksi semua. Dan ni G versus omega radian per second. Dan ni pun sama, omega radian per second. Okey, ni contohnya kita akan plot. Okey, ni kita ada wakilin 1, 10, 100, 1000 and 10,000. Maaf jika tak nampak. Okey, ni contoh je. First kita tengok dekat omega radian per second to dB. Kita nak cari dB. So kita abaikan degree yang bawah ni, kita cari yang ni. So kita dah buat skala tepi ni, kita kena pandai bahagikan. So ni 0.1 37. Okey, so saya anggarkan 37 antara sini, 40 bawah dia sikit, dan 0.1 kat sini. Start permulaan dia. Okey, second dia cari 0.5 and 24. Okey, ni antara 20 atas sikit 24. Okey, ni graf tak berapa jelas, dan itu sekian. Kita akan ikut turutan sama 1.0 dan 17. Kita plot sama sampai ke akhirnya. Okey, seterusnya kita akan buat graf kedua pula. Ini graf kedua. So kita boleh abaikan dB ni. Kita tengok antara 0.1 dan negatif 90 ni. Omega radian per second and degree. So kita buat benda sama juga. Kita ambil titik ni, dan titik ni kita plotkan. Lepas tu ambil nilai ni kita plotkan, dan akan dapat satu curve macam ni. Lepas tu bila dah siap graf ni, kita perlu cari GM, iaitu gain margin. Okey, gain margin pula kita akan tengok dari kosong. Dari kosong kita tengok mana kena, kita ke bawah, dan kita dapat nilai dia, iaitu kita kosong point X. X tu nilai yang kita dapat bila dapat bertemu. Okey, lepas tu nak cari phase margin pula. Kita cari dari 180 tambah Y. Y ni adalah nilai yang kita dah dapat bila dia bertemu. Okey, ni contoh kita bertemu kat sini, kita tarik ke atas dan kita dapat ke sini. Okey, so bila kita dah dapat nilai dia, ini 9.6 dB dan ni 43 degree. Okey, so jika nilai GM dan PM dia positif, maka kita boleh nampak sistem ni stabil. So sepatutnya ayat ni kita perlu letakkan dekat graf ni. So lengkaplah graf kita. Okey, itu saja daripada saya. Sekian, terima kasih.